All right, so we're going to start this discussion of more biological approaches with neurons and neurotransmitters. And I just want to pause before we do and talk about the fact that we are living in a time when biological paradigms are very central to understanding psychological disorder. And that's true, I think, even for those of us who are not medically trained and don't prescribe, that the idea that for many people their biological makeup is an important part of what is informing their disorder is something that I think most, again, most competent therapists incorporate that. Even if it's not going to be part of their treatment, it may be part of their treatment recommendations. So I don't prescribe medication, but I often will refer to psychiatrists or psychiatric nurse practitioners, or even to somebody's family doctor to get medication to be one of the tools that are used to help this person. And again, I maybe I haven't said this specifically. I think the idea of being client-centered means you are willing to use whatever tools is going to help this person in front of you, and you're not going to say, I don't believe in medication, or I don't, I'm not going to become informed about cognitive behavioral therapy. That you have tools in your toolbox to help people, not, and you don't only use tools that you like or that you prefer. And so medication is a tool. But it's an important tool. But right now, when I was being trained, if we will go back 30 years or so, medication was less of a big part of our understanding. That the biological paradigm was less central to how we understand psychological disorder. We didn't understand the genetics of psychological disorder very well, but as our understanding grows, we incorporate the importance of these things more and more. And that does kind of touch on an important point that I haven't made yet, which is that things become a little fashionable, paradigms become fashionable or trendy, and often that follows what our newest information is. And right now, our newest information is biological, especially genetic, and also we understand way more about what's happening in the brain for certain disorders than we have in the past. And so the newness of that information makes it particularly of interest to us right now. But we're going to start by talking about neuroscience, and that means talking about neurons and neurotransmitters. And all of you have had Psych 111. I'm going to start with the assumption that you remember how neurons communicate. And I would suggest to you that if you don't remember the basic electrochemical steps of communication for neurons, that you go back to your Psych 111 material or find some information online to just refresh your memory about that basic idea that a neurotransmitter enters the receptor site that causes an immediate change in the permeability of the neuron. That permeability allows positive ions to come rushing in. We get a change from a negative baseline charge to a positive action potential that moves in a wave-like fashion down the neuron until it reaches the axon terminal buttons, at which point the neurotransmitter is released back into the next synapse, and the cycle starts again. So that's a very quick overview. Just, basically, if you're listening to that and thinking, yep, 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 then you are good. If you're listening to that thinking, what, I don't remember that, or I vaguely remember, then go back and look at that material again. Because it's hard to understand the specifics we're going to talk about if you don't understand those basic principles. So the more specific things we are going to talk about, I want, the list is here. I'm going to take them one at a time. We're going to talk a little bit about agonists, and that becomes important when we're thinking about medication, and also antagonists. And most of you are more familiar with the word antagonistic, or to antagonize somebody is to work against them. And that's a way of understanding these two words, that an antagonist is working against a neurotransmitter. It makes it harder for the neurotransmitter to send the messages that it wants to send. And so we might introduce medication that are antagonists that therefore interfere with the ability of certain messages to happen. Agonists do the opposite. They enhance the ability of a neurotransmitter to send its message, and so essentially we're amplifying. And so, I often want to use the analogy here that antagonists turn down the volume of certain messages and how certain neurotransmitters are used, and agonists turn up the volume. You hopefully remember the idea of reuptake from your basic Psych 111 stuff, but it's worth mentioning again here because it becomes very important to our understanding of how some disorders are happening, but even more so how some medications are working. And so it's something we'll come back to several times. And so reuptake, if you'll remember, is after the neuron fires, neurotransmitter is sent into the synapse. Some of those neurotransmitter molecules lock into the receptor sites of the next neuron, and then that neuron fires. But after that happens, the presynaptic neuron, the sending neuron, almost always sends out more neurotransmitter molecules that are needed to make the next one fire. And so we have extra molecules floating around the synapse. And if they're left there, they will, by accident, float to the receptor sites of the postsynaptic neuron and make that neuron fire again when we really only wanted one message. And so reuptake prevents that. Reuptake, essentially, there are transporter molecules that attach to the neurotransmitter molecules and bring them back to the presynaptic neuron. And we will talk about medications, and most specifically serotonin, selective serotonin reuptake inhibitors, SSRIs, which are the antidepressants and anti-anxiety medications that so many of you are familiar with, even if it's just from television commercials. But I'm willing to bet that almost everyone in the room, everyone in the class knows somebody, and it may be you, but if not you, then knows somebody who's been on these medications because they're so commonly prescribed. So these are things like Prozac and Paxil and Zoloft and Lexapro and others that are selective serotonin reuptake inhibitors, and their job is to prevent the reuptake of serotonin in certain synapses and to leave extra serotonin available to the person. But we'll talk more about that in the mood disorders chapter. And then the other thing that I bet lots of you are not familiar with is the idea that we have individual variation in how sensitive our postsynaptic receptors are. So I keep mentioning these receptor sites, and some, an individual person may have receptor sites that are more sensitive or less sensitive to a neurotransmitter. And the analogy I always use here is about ticklishness, that some of you are very ticklish, you have high sensitivity to ticklishness, and therefore it doesn't take much tickling to make you laugh. Some of you have low sensitivity to ticklishness, and it would take a lot of ticklishness to make you laugh. And and so I want you to think about that analogy when you're thinking about the sensitivity of postsynaptic receptors, that if a receptor is very sensitive, it doesn't take much neurotransmitter to make that neuron fire. If the postsynaptic receptors are not very sensitive to a neurotransmitter, then it takes more of that same neurotransmitter to make that fire. And so if you're an individual with a high sensitivity to serotonin, which we were just mentioning, right? You have a high sensitivity to serotonin, then you don't need very high levels of serotonin to keep everything working. But if you have low sensitivity to serotonin, you are going to need more serotonin available to you to get the same effect that most other people get. And we will talk about this in various ways, but we will certainly talk about this when we talk about schizophrenia and dopamine, because this is what's happening, the problematic thing that's happening with dopamine for people with schizophrenia. So we'll come back to that. I want to briefly talk about these neurotransmitters. Hopefully, again, you remember these names from Psych 111. I'm thinking most of you probably went over these, but these 5 neurotransmitters really are going to be the 5 that you and I talk about most. Serotonin is going to come up again and again, starting with mood disorders, but also with anxiety disorders, and also with obsessive compulsive disorder, and also with eating disorders, etc. The serotonin is about regulation. So people tend to think about this as a happy neurotransmitter, and that's not really accurate. It is about making the person, about regulating mood, regulating sleep, regulating appetite, and so it's keeping those things on track. It also is, I think, another way of thinking about serotonin is that it's a resilience neurotransmitter. that when our serotonin levels are inadequate, we feel more brittle and less able to deal with stressors, and that when our serotonin levels are adequate, we feel more resilient, and that even when things are stressful, we're more likely to come up with ways of meeting that stress productively. Dopamine, hopefully many of you know, is in our reward system. It is our reward neurotransmitter, and reward is really important to sustaining lots of behaviors. So if you want to keep seeing food as something to eat and not develop anorexia, for example, you better find food rewarding. And if you don't find food rewarding, think about how much less likely you were to seek out food. And so you hopefully, you eat food, you get a little dose of dopamine in your brain, and you say, ooh, I like that, I'm going to keep eating. If too much of that happens, you may keep eating beyond when it's healthy for you to keep eating. If you're thinking about depression and thinking about sustained behavior and motivation for behavior, we feel motivated to do things when we have come to expect that there will be a reward, essentially in the form of dopamine in our brains, at the end of the behavior. And people who are depressed often don't sustain behavior. They start behaviors and stop them before they're finished, in part perhaps because they have no expectation from their experience that they're going to feel good in the way that most people feel good upon finishing a task or a project. So dopamine will be one that we talk about as well. GABA is our essentially anti-anxiety neurotransmitter. GABA is inhibitory. It quiets your brain. And so often when we're feeling anxious, what we want is to make our brain more quiet. And we might use substances that increase GABA. And things like Xanax, which people often take for anxiety, is a GABA-based medication. But alcohol also is GABA-based, and both of those things are often used by people to quiet their brain, to make them less less worried, having a brain that's doing fewer things and therefore is calmer. Glutamate's the opposite of that. Glutamate is activating. It's an excitatory neurotransmitter in our central nervous system, and it is important to learning and memory. It keeps our brain active and focused. Medications for attention deficit are glutamate based. They help focus your brain, and so they're activating, which is often considered paradoxical, but in their activation is about focus. It's about the activation of our executive function, essentially. And then noradrenaline becomes important in treating depression sometimes. And it is, again, a very straightforward excitatory neurotransmitter. When people are having depressive symptoms that are largely about low energy and too much sleep and not being able to get themselves to do things, medications that involve noradrenaline might be really helpful in kind of activating them in an overall way. We will come back and talk about each of these as we talk about specific disorders. So this is just kind of an introduction, and so I know I'm going a little fast and skirting the surface a bit, but more I'm just pointing and telling you to make sure you read about these and to make sure that you tuck these names away and have some general idea of them, so that when we get to the more specific conversations, you can make sense of those. We're going to pause here and go to the next video to pick up with continuing our talk about biology.